Okay, this part is from section 8.1, number 29. The amount of time Americans spend watching television is closely monitored by firms such as A.C. Nielsen because this helps determine advertising pricing for commercials. Part A states, do you think the variable weekly time spent watching television would normally be distributed? If not, what shape would the variable have? Well, you could put that it would be skewed to the right because it's more likely that people watch more television on weekends than normally throughout the week because they have jobs or whatever, etc., school, so they don't spend as much time if they were watching TV as in the weekends. Okay, that's what I put. So for part B, according to American Time Use surveyed, adult Americans spend 2.35 hours per day watching television on a weekday. Assume that the standard deviation for time spent watching television on a weekday is 1.93. If a random sample of 40 adults Americans is obtained, describe the sampling distribution of X bar. The mean amount of time spent watching television on a weekday. Okay, so how will we start this? Well, first we have to identify what our mean is. In this case, we got a mean of 2.35. That was the mean that was originally given. Okay, and it says right here that time spent watching a standard deviation for time spent watching television is 1.93. So, and then we took a sample of that to be 40 adults. So we come over here. Okay, so we have a mean of 2.35, standard deviation of 1.93, and it was a sample of 40. So the way we start this is it's always assumed that the mean of will be always equal to the mean of X bar, which it stays the same. The standard deviation can be found by dividing the standard deviation that was given over 40 square root, which would give you about 0.305. So that would be the average time spent watching television on a weekday. To determine the probability that a random sample of 40 adults Americans result in mean time watching television on a weekday of between 2 and 3 hours, the way we start this is basically what we did before. Is we use probability between what is the probability that it spends between 2 and 3 hours watching television. So basically we just do a normal CDF with 2 being the lower bounds, 3 being the upper bounds, 2.35 being the mean, and the standard deviation that we found for 40, because we're sampling 40 for part C, not the whole population, but just the 40. So that's the standard deviation of the 40, which you get about roughly 0.8578. Okay, for part D, one consequence of the probability of the internet is that it is thought to reduce television watching. Suppose that a random sample of 35 individuals who consider themselves to be avid internet users result in a mean time of 1.89 hours watching television on a weekday. Determine the likelihood of obtaining a sample mean of 1.89 or less from a population whose mean is presumed to be 2.35 hours. Based on the result obtained, do you think avid internet users watch less television? So the way that we start this is they basically gave us what we're looking for, which is the probability that X bar is going to be less than or equal to 1.89. We know they gave us the sample size, which was 35. So basically we just use what we had originally had for our standard deviation, which was 1.93. That was for the whole. And the new sample size, which was 35 square rooted, gives us about 0.32622295423. And basically it's a normal CDF function. So we're trying to find X bar being less than. So our lower bounds is going to be negative infinity. Upper bounds is the mean that was given, which is this one, because we're trying to find mean averages. And then the other mean, which is from the original one, from the whole, is 2.35. So the standard deviation, we got it from up here, from this one. So that's what we use. So we calculate it on our calculators and we roughly get 0.0793. And that's how you do it.